your time and want to retake your timed unit circles test, you can do that after notes. And today is a great day. I'm super excited. We are graphing. This whole unit, except for the very last couple of lessons, is all about graphing, which is fantastic. I love teaching graphing trig functions, so it is my favorite thing.
What page is that?
We have transformations on ours.
Translation, I think like that.
Oh, no.
That's the wrong packet.
Yeah.
Yeah, Whoops, Daisy. That was the... Oh, man, that was geometry's packet. I'm so sorry. Will you cross out your names if you put your name on there? I totally passed out the wrong packet. I'm so sorry. Here. I will staple it back. Okay. All right, give me those back. Oh, man, I can't believe I did that. Thank you. I apologize. My fault. Oh, man. Okay. Thank you. All right. Whoops, Daisy. That was funny. Okay. Just kidding. My bad. 1, 2, 3, 4. Tasha, pass it back.
Wait, you don't say
Can we write our name? Probably not gonna go.
There you go. Yeah, this is actually the right packet. Apologies. Oh my goodness. Okay. Okay, that's a match. Oh my lord. Okay. Okay. Okay, here we go. All right, now that we have the right packet, sorry about that. I should think before I hand things out. We are graphing sine and cosine functions today, and I love doing this. And what I really love is finally learning fractions. So today we're doing fractions. Okay. So we want to be able to graph sine and cosine curves. And so here we have our regular sine function. And it comes from our lovely little unit circle. And we're just going to go ahead and make a little simple circle and dot unit circle here on the side. And we're starting here at 0 radians. What's the ordered pair at 0? Yeah, 1, 0. Okay. And so what happens here is we're going to graph this curve and go ahead and just draw a vertical axis and a little horizontal like that. And we're graphing this curve, and our x-axis represents the radian measure, the radian angle measure. Okay, so we're starting here at 0. And we're going to graph this curve all the way around. We're going to graph one full rotation, so we're going to end at 2 pi. And so on my x-axis, I'm going to end over here at 2 pi radians. And I'm starting here at 0 and ending at 2 pi. Now, then, let's say I'm going to go and right here, and it'll go, here's a really nice point right here. What's the radian measure right here? Pi over 2, yeah, so at pi over 2, let me see. And then if I go here, I'm going to go here. That one is pi, and then here down at the bottom is 3 pi over 2. Those are all cut really nice. So what I'm going to do is I'm going to go, and I have my 0 and my 2 pi. I'm going to go right to the middle. Always do the middle first. What's right in between 0 and 2 pi? 1 pi. And so again, I'm going to cut it in half. That's what Martha Stewart says. If you want to do a really nice job cutting brownies, you always cut down the middle first, and then get the middle of that, and then do the middle of those, okay? And you'll always get really good brownies, okay? All right. So we're going to do the same thing. What's right in between 0 and pi? Yeah, pi divided by 2, okay? And if this is 1 pi over 2, and this is, oh, hey, 2 pi's over 2, then what's this one? 3 pi's over 2, and this becomes 4 pi's over 2. So I always start by dividing my x-axis up, my radian angle measures up, just this way, splitting them in halves. And then what we can do now is we can actually plot our sine values. So around our unit circle, we're going to travel around our unit circle starting at 0, and I'm going to go up here at pi over 2. What's the ordered pair here? 0, 1. And at pi, what's our ordered pair? -1, 0. And then at 3 pi over 2, what's our ordered pair? 0, -1. Okay. So now what we're going to do is we're actually going to plot the sine values as we travel around our unit circle. So as I'm moving around this circle, starting here at 0 radians, what's the sine value? The y-coordinate is the sine of our angle theta equals 0. So at 0, I'm plotting a 0. At pi over 2, what's the sine value? 1. Yeah, so I'm going to plot a 1. So right there, I just have a 1 on my vertical axis. So at pi over 2, it's the sine value of 1. And then I'm traveling around my circle, I hit pi. What's our sine value? What's the sine value? 0. Yeah, oh, we're back to 0. And again, traveling around my unit circle, I'm at 3 pi over 2. What's the sine value? -1 now. So I need a -1 on my vertical axis. So at 3 pi over 2, we're at -1. And then I go back to 2 pi, and what's my sine value at 2 pi? 0 once again. And so the question can I only go one time around the unit circle? Can I keep going? Okay. So this is called a periodic function. This is the sine curve. It's nice and curvy, okay? And it has a lovely little song. So this is the sine song. The sine song says, middle, high, middle, low, middle. Already, ready? Middle, high, middle, low, middle. Okay, again. And middle, high, middle, low, middle. Okay? Middle, high, middle, low, middle. Okay, that's the sine song. So I want to hear lots of singing today as you make your graphs, okay? And that works really, really great. Okay, that's the sine song. This is an example of one period. This is one period of the sine curve. After this, it just starts to repeat itself. It continues on in the same middle, high, middle, low, middle period function. And it just continues on in either direction, a nice graceful curve. All sound waves are sine functions. It's very cool, but we can really see all these curves when we look at little bouncing pieces of sand over sound, low sounds, like a subwoofer. It's very cool to see what happens. All right. So now this is one period. It has a length here of 2 pi. It takes 2 pi amount of time before it starts repeating, okay? And we also want to know it has an amplitude. The amplitude talks about, well, when we think about amplitude, it's like how loud it is, right? When we talk about a speaker, right? Like the amp, right? So amplitude is the distance from the middle, all right, up to the highest point. That's amplitude. I'm going to put an A there, amplitude. The amplitude is how tall that wave gets, okay? And that amplitude can change based on numbers that we add to our basic function here, okay? Now let's do the cosine curve. Again, we are going to grab a vertical axis and a horizontal axis. And again, we're rotating around the unit circle, so we're going to start at 0 and end at 2 pi. And I'm going to go ahead and cut that in half. What's halfway between 0 and 2 pi? 1 pi. What's halfway between 0 and pi? Yeah, 1/2 pi, or pi over 2. And if I have 1 pi over 2, and this is 2 pi over 2, what's the next way? Halfway. 3 pi's over 2. See how that works? Okay. And if you subdivide this way, your graphs are always going to be perfect. And this is why I love teaching this. I love seeing beautiful graphs. Okay. I'm talking to you, Will. I want to see beautiful graphs from you today. All right. And we're also using the unit circle, which is, of course, just a single unit. And so we really are going to have a maximum of 1 and a minimum of -1, just like before. But cosine is a little bit different. So now we're graphing the cosine values as we rotate around our unit circle. So starting at 0 radians, what's our cosine value at 0? Yeah, so cosine of our angle measure is just the x-coordinate, so it's just 1. So at 0, we're actually up here at 1 on the unit circle. That's the high point. And then we go to pi over 2, and what's our cosine value? 0. So at pi over 2, we're going to plot a 0. And then at pi, what's our cosine value? Now we're down low at -1. And then at 3 pi over 2, what's our cosine value? Back to 0. And then we circle all the way around, a full rotation back to 2 pi. What's our cosine value? 1. And so at 2 pi, we're at a height of 1 at the maximum. Okay, this is the cosine curve, and it is rounded. It is not a V. It is nice and rounded. All right, so curve those down. It does continue, just like sine, in this nice curve. They are, in fact, the exact same curve. One is just shifted over a little bit. Shifted left or so, if you will. It's just the slide. So this is the cosine curve, and cosine has a beautiful song. Cosines, can you guess it? High, middle, low, middle, high. Okay, your turn. Ready? And high, middle, low, middle, high. Oh, one more time. And high, middle, low, middle, high. Okay, so that's the cosine curve. High, middle, low, middle, high. Okay, and so that's the cosine curve. It's really, really great. And again, it also starts to repeat. Right here, starts at 0, ends at 2 pi. That is 1 period. It takes 2 pi amount of rotation before it starts to repeat over and over and over again. And again, it also has, in this case, the amplitude from the middle to the highest point. That amplitude is 1 in this case. Now, these are our basic functions, the sine function, middle, high, middle, low, middle, all right, or the cosine function, high, middle, low, middle, high, all right. I never was in choir, but I wanted to be always wanted to be in choir. So after high school, I joined my church choir, so then I was in church choir. But yes, I sing in choir. Okay, I love to sing. The cosine song and the sine song are very, very similar, but we want to keep them straight, okay? That's why the singing helps. But if we add in extra values to our very basic parent function here, we can change how tall that sine or cosine function curve is and whether it has a horizontal or vertical shrink in there, so it can be stretched too, okay? So, I want to skip down right here. Given we have these transformations that we're adding on here, the A is being multiplied to our curve, whether it's a sine curve or a cosine curve. What happens to our sine and cosine curve if we multiply it by a number? What's going to happen to it? Well, so I'm taking the height here, like so the sine value is 1. If I multiply it by a number like 3, what's going to happen to that 1? It becomes a 3, okay? So this number in front is the amplitude A. We always talk about amplitude as a positive value, so it's always the absolute value. The amplitude is the absolute value of whatever that A value happens to be. It's going to be the vertical stretch. It's going to stretch our curve taller, okay? Now, a number in front of the x, a number with x, changes things in the x direction, all right? So that number with x is going to affect the horizontal axis, all right? And so that affects the period. And the period changes, everything with x is always opposite, but the period is 2 pi over b, whatever that b happens to be, whatever that number happens to be, we are going to take our original period and divide it by that value, and that's going to tell us how much our horizontal changes, okay? Period is p, period equals 2 pi over b. All right, so number 1 here, identify the amplitude and period. What's the number in front of our sine function here? 1. Okay, so what's the amplitude? 1. And what's the, we want the period. The period equals what? 2 pi over 4, which would be 1/2 pi, or pi over 2. Yep, that reduces. Okay. All right, what is our amplitude on number 2? And what is our period? No. Period is 2 pi over 1, which is just 2 pi. The b is 1 in this case, so 2 pi over 1. Okay. All right, number 3, what is the amplitude? Okay, careful. 5. It is just 5. What does the negative do? Right, well, amplitude is always a positive number, okay? What does the negative do to the function, though? It flips it, yeah. So if you're a sine song, you would normally be middle, high, middle, low, middle. But if you've got a negative, it would be middle, low, middle, high, middle. Does that make sense to you? All right, so that negative still flips things, just like before. All right, and the period is going to be 2 pi over 1/3. 2 pi over 1/3. How do I deal with 2 pi divided by 1/3? Multiply by the reciprocal. It's 2 pi times 3 over 1. Multiply by the reciprocal. That's going to give me what? 6 pi. Very good. Okay. Multiply by the reciprocal. All right. What is the amplitude on number 4? 2. What is the period? 2 pi over 4/3. How do I deal with dividing by a fraction? Multiply by the reciprocal. So it becomes 2 pi times 3 over 4. So we're going to get 6 pi over 4, which will reduce to 3 pi over 2. Very good. Okay, are you good so far? Okay, great. All right, turn the page. All right, so what we're going to do, and I have a very specific way for you to graph. We're going to identify the amplitude and period and then graph the functions. So first starting, what's the amplitude? 2. And what's the period? 2 pi over 1, which is just 2 pi. Okay, the 1 is in front of the x, so the period is just 2 pi. Always we have a vertical axis and a horizontal axis. So on your paper, you should have a vertical axis and a horizontal axis, just like I've drawn. And when we have this period, it's going to start at 0 and it ends at 2 pi. And we want to subdivide that horizontal axis. So we're going to cut it in half. What's halfway between 0 and 2 pi? Pi. And what's halfway between 0 and pi? Pi on 2, pi over 2. And then that's 1 pi over 2, 2 pi over 2. What's the next one? 3 pi over 2. See how that works? Okay. Now my amplitude is helpful. Now instead of having an amplitude of 1, now we have an amplitude of 2. Yeah, so our maximum now is 2, and what's our minimum going to be? -2. So see how that works? That's really, really easy. Okay. Now, in order to graph this curve, we are graphing the sine song. What's the sine song, ladies and gentlemen? Middle, high, middle, low, middle. So we're going to graph middle, high, middle, low, middle. Every note you sing is a dot on the graph. See how that works? All right, and then you can connect the dots in a beautiful, smooth, rounded curve like that. And it'll be perfect every time. Okay? Let's try another. All right, let's look at number 6. All right, what's the amplitude? 5. And what's the period? It's 2 pi divided by 1/2. How do I deal with that? So it becomes 4 pi. Very good. So I have my vertical axis and I have my horizontal axis. I'm going to deal with my horizontal axis first. It starts at 0 and ends at 4 pi this time. Oh, this is a change. This one's getting stretched longer. It's taking more time to complete its cycle. So what is in between, what's halfway between 0 and 4 pi? 2 pi. Okay, very good. And what is halfway between 0 and 2 pi? Oh, 1 pi. And so 1 pi, 2 pi, 3 pi, 4 pi. Okay, great. Good job. All right, and what's our maximum and minimum? 5 is the max and -5 is the minimum. And now we're singing the cosine song. What's the cosine song? High, middle, low, middle, high. Okay, here we go. At 0, we go high, middle, low, middle, high. Okay, and then you put nice, smooth, beautiful curve, ladies and gentlemen. Okay? Have you ever drawn such pretty curves? Okay. All right. Number 7, what's our amplitude? 3/2. And what's this negative do? It's going to flip it. So I want you to write that down. That negative is going to cause our graph to flip upside down. How do we figure out the period? 2 pi over 4, which becomes pi over 2, or 1/2 pi. All right, so I have a vertical axis and a horizontal axis. Now I have to do the horizontal axis first. That's my period. It starts at 0, and where does it end? At pi over 2. So now, ladies and gentlemen, here's where the real math begins. What's halfway between 0 and pi over 2? Yeah, 1/4, 1/4 of pi. Okay. All right, and then what's halfway between 0 and pi over 4? Yeah, pi over 8. Very good. How we're doing this, really, it's 0 plus pi over 4, and then we're cutting it in half. We're dividing it by 2. 0 plus pi over 4 is pi over 4, but when we would divide it by 2, that multiplies by the reciprocal, so that's where we get the 8, all right? So that becomes pi over 8. All right, so this is 1 pi over 8. This could be 2 pi's over 8. What's this one going to be? 3 pi over 8, and then this would become 4 pi over 8. Does that make sense? Isn't it amazing how it just all makes sense? Like when you just, okay. So my rule of thumb is don't reduce, because it's actually a lot easier. Okay. All right, what's our maximum and minimum? Yeah, 3/2 and -3/2. Very good. Okay. And we're doing a cosine song. What's the cosine song? High, middle, low, middle, high, but it's flipped. So what's our cosine song now? Low, middle, high, middle, low. Okay. So low, middle, high, middle, low, low, low. Okay. Wow, okay.
Mine looks better than I messed up.
All right. What's our amplitude? 1. What's the negative doing for us? Flipping it. What's our period? How do we figure out the period? 2 pi over 8/3. How do we deal with that? 2 pi times 3/8, so multiply by the reciprocal, so that gives me 6 pi over 8. Which reduces to 3 pi over 4. Okay, 3 pi over 4. All right, so I have my vertical and my horizontal, so I'm starting at 0, and where do I end at? 3 pi over 4. All right. What is halfway between 0 and 3 pi over 4? Careful. So 0 and 3 pi over 4. And what's halfway? So that's 3 pi over 8. 3 pi over 8 is what happens there. So again, copy this down. This is how I'm figuring this out. We're adding together and dividing by 2. This is a midpoint formula is all it is. That average. Adding them up and dividing by 2. This is 3 pi over 4 divided by 2. That becomes 3 pi over 8. Or multiply by a half, if you will. All right, and then, so what is, this is another way you could write it. What is halfway between 0 and 3 pi over 8? That's another way you could write it. That's a great way to write it. What is halfway between 0 and 3 pi over 8? What do we get? 3 pi over 16. 3 pi over 16. Well, hey, that's really interesting. Okay, 3 pi over 16. Ooh, what's this one? Yeah, if I want them all to be the same denominator, this would be, if I could multiply by 2, so 16, so this would be 6 pi over 16. 3 pi over 16, 6 pi over 16. What would the next one be? 9 pi over 16. And then this one, if we multiplied by 4, that'd give me 12 pi over 16. Do you see how that works? Is that kind of interesting? Okay. What's our max and min? What's our max and min?
Oh, maximum
1 and -1. Okay. We're singing which song? The sine song, but it is middle, low, middle, high, middle. Okay. Middle, low, middle, high, middle. That was in a minor key. Okay. Okay. All right, last one here. Last one here, Scott. Last one. Why doesn't he have a pencil? You broke it? Thank you, Avery. All right. Number 9. What's the amplitude? 5 over 2. What does the negative do? Flip it. And how do we figure out the period? 2 pi over 2/3, which we have to, times by 3 over 2. That becomes 6 over 2 pi, which is just 3 pi. Okay. So I have my vertical and I have my horizontal. We start at 0 and end at 3 pi. All right. I want to find a halfway point. What is halfway between 0 and 3 pi? Keep it as improper. 3 over 2 pi, 3/2 pi. Okay, good. All right, I encourage you to write this down because this will help later. Write that down. Write that little cheat code right there. All right, and I get the halfway point here. That one is halfway between 0 and 3/2 pi is 3 over 4 pi. 3 pi over 4. Yep, you just multiply straight across when we write it like this. That's easy. This is the easy way. All right. So this is 3 pi over 4, 6. Yeah, if I multiply by 2 there, that will give me 6 pi over 4. 3 pi over 4, 6 pi over 4. What would come next? 9 pi over 4, and that would make this 12 pi over 4, which then reduces to 3 pi. You see how it works? I just thought it was just the coolest thing. I didn't ever notice it when I was in school because my teacher never pointed it out that there's a pattern there. Okay, don't reduce. Reducing sucks. Like, it's better if you don't reduce. 3 pi over 4, 6 pi over 4, 9 pi over 4, 12 pi over 4. It's perfect. All right, what's our maximum and minimum? 5 halves and negative 5 halves. Very good. And this is flipped, and we're singing the cosine song. So what's this song going to be? Low, middle, high, middle, low. Okay. Low, middle, high, middle, low, low, low. Okay? You think you can handle it?
Yeah.
Yeah? No, it's a worksheet today. And I want to see all those horizontal points. Work those fractions, ladies and gents. They're going to be fun. I want to see all those midpoints.